All right, welcome to class, everybody. Our lesson today is section 7.3. So we'll go ahead and do the beginning part where I'll teach you guys the concept, and then I'll let you guys know when you can start working on your homework. So section 7.3 is all about simplifying radicals, specifically when the radicals don't simplify to a whole number. So for example, if you were simplifying the square root of 36, what would that equal? Everybody call it out. What would be the square root of 36? 6. Now, the square root of 32 will not simplify to a whole number because there's not a whole number if you multiply it by itself that equals 32. But we can still simplify it. So I'm going to show you how to simplify it by using 36 as an example. So we already know the answer is 6. One way that we could get this answer, though, is we could get 36 and break it down into its prime factors. So we could say 36 equals 6 times 6. 6 can be broken down into 2 times 3. And 6 can also be broken down into 2 times 3. So if I wrote out the square root of 36 in factorized form, I'd have 2 times 2 times 3 times 3. Now, the multiplication rule of square roots says that if you have stuff that's multiplied together inside of a square root or a cube root or any type of root, that you can separate it out into multiple square roots. So I could rewrite this as the square root of 2 squared times the square root of 3 squared, because I could take this part and put it in a square root, and then I could take this part and put it in a square root. Now, if you square root something that is squared, the square root and the squared undo each other. And so the square root of 2 squared would just be 2. The square root of 3 squared would equal 3. And 2 times 3 equals 6, just like we already knew the answer was. So this is the method we're going to use to simplify things that don't equal perfect squares. If it's a perfect square, you really don't have to go through this whole process because you can just kind of figure it out based on your multiplication tables. But when you have something like the square root of 32, the way that we simplify it is by looking at their prime factors. So 32 equals 4 times 8. 4 can be factored into 2 times 2. 8 can be factored into 2 times 4, and 4 can be broken up further into 2 times 2. So there's 1, 2, 3, 4, 5 factors of 2 in 32. So I can rewrite the square root of 32 as 2 times itself 5 times. Is everybody good with that? Okay, so now since I'm doing the square root, I want to look for squares because square roots and squares undo each other. So I'm going to basically look for pairs of factors, and I can rewrite this as the square root of 2 squared times the square root of 2 squared times the square root of 2. So this pair of 2's became the 2 squared, this pair of 2's became this 2 squared, and then this 2 didn't have another 2, so it's not 2 squared, it's just a 2. And that's going to equal the square root of something squared just equals that thing. So this is going to equal 2. This will also equal 2. And this can't be simplified any further. And so that's the square root of 2. And that means this is going to equal 4 times the square root of 2. And this is the simplified version of the square root of 32. All right. Any questions on this so far? Okay. Now, just so you guys know, I don't usually write these 2 steps out. When I'm doing this in my head, I just look at this and I look for pairs of factors that match. What you're actually doing is this. You're saying like, oh, well, if I have 2 squared, then the square root of that will cancel out to 2. But when I'm doing it, I'll usually just say, okay, well, the square root of this is going to be 2. The square root of this is going to be 2. And then this one can't be simplified at all. And I kind of just do it in my head. But if you want to, you can write it out, or you can just kind of do it from that step. All right, let's do another example of this. So let's say that we have the square root of 392. If we wanted to simplify this, the first thing we need to do is break it up into its prime factors. So since it ends with an even number, I know that it's divisible by 2, and 392 divided by 2 would be, I want to say 196. Someone want to check that on your calculator? I think it's 196. Cool. And that's an even number, so I can divide by 2 again, which would give me 98, maybe. And then that's an even number, so I can divide by 2 again, which would give me 49, I think. And then 49 factors into 7 times 7. Is that the correct factorization? I'm not sure if I did this part right. Is 98 divided by 2 49? Okay, awesome. So the prime factorization of 392 is 2 times 2 times 2 times 7 times 7. So since I'm doing a square root, I want to look for things that are squared. So I'm going to say, okay, well, here's a pair of 2's. If I square root 2 squared, that's going to equal 2. I also have a pair of 7's. If I square root 7 squared, that's going to equal 7. So I'll have 2 times 7. And then this 2 didn't have another 2 to go with it. So that's just the square root of 2, and you can't simplify that any further. So my answer, it looks like it's going to be 14 times the square root of 2. Is everybody good with how I got that? And again, you could write the middle step. So the middle step looks like you're doing the square root of 2 squared times the square root of 2 times the square root of 7 squared. That's essentially what I talked through here. So I don't usually write this out, but if it's helpful for you, you can write that step out to get this. All right, so that's how you do, or how you simplify the square roots for big numbers. You basically just break it down until all of the factors are prime numbers, and then you look for pairs. And this is also the way that you do cube roots or fourth roots or things like that. Because if I wanted to find the cube root of 135, I would start off by getting it into factored form. So since it ends in a 5, I know that it's divisible by 5. I don't know what it is though. What's 135? What is it? 27. Okay, awesome. And then 27 can be factored into 3 times 9. 9 can be factored into 3 times 3. So this is the cube root of 3 times 3 times 3 times 5. Now, I'm doing a cube root, which means that I'm looking for things that are cubed. So I'm going to say, okay, well, I have 3 3's multiplied together. So I could rewrite that as the cube root of 3 cubed. That's a lot of 3's in different spots, but is everybody good with that? And then I could say that is times the cube root of 5. Now the cube root of 3 cubed can be simplified because cube roots and cubes undo each other. So that's just going to simplify to 3 times the cube root of 5. And the cube root of 5 can't be simplified any further. And so this would be your simplified answer. So it's basically the same process as what we were doing, except instead of looking for pairs of matching factors, you're looking for triples. Does that make sense? And like you'll have other problems on your homework where you're doing like the fourth root. And if you're doing a fourth root, you're looking for quadruples of the same factor. Or like the fifth root, you'd be looking for factors to the 5th power. Any questions on that? Let's maybe do a check-in scale of 1 to 5. How are you guys feeling about that? Okay, awesome. Then let's do an example with some variables, and then I'll let you guys start working on your homework. So let's say that we had 128 x to the 7th, y to the 6th, and we were finding the cube root of that. Well, if I wanted to simplify this, I basically need to find out if there's any cubes in that root that I could simplify by taking the cube root of them. So I'm going to start with the number part, and I'll say 128 is an even number, so it can be factored into 2 and 64. That's an even number, but also I could factor into 8 times 8 because I know 8 times 8 is 64. 8 can be factored into 4 times 2. 4 can be factored into 2 times 2. And that other 8, same thing. So it looks like my prime factors are 1, 2, 3, 4, 5, 6, 7 twos. So I have the cube root of 7 twos multiplied together and 7 x's and 6 y's. So this is the expanded factorization of this expression. Oh, my battery is like really low. And so since I'm doing the cube root, I want to look for cubes. So I'll say, well, the cube root of these 3 twos will equal 2 because the cube root of 2 cubed just equals 2. The cube root of these 3 twos will be another 2. The cube root of these 3 x's and these 3 x's will be x squared. Well, actually, maybe I'll write them out. So I'll have an x and then another x because the cube root of each of those triples will be just an x. Same thing with the y's. So the cube root of 3 y's and another 3 y's will each be a y. And then I want to look at what didn't get cube rooted. So I say, okay, well, all of these 2's became these, but this 2 did not. So that 2 is going to stay inside of the root. And then this x will also stay inside of the root because there wasn't enough 2's and enough x's to be able to cube root that part. Then you can just simplify this stuff and you get 4x squared y squared cube root of 2x. And this would be the fully simplified version of that root. Yeah. When you say one left of them,
Like there's, so you have 2 pairs of 3 twos, right? So
Mhm.
that only gives you like 1, 2. And
yes.
the x's.
Yeah, so this triple of 2's is 2 cubed. When you do the cube root of 2 cubed, you get this 2.
Right.
But then this triple of 2's will give you another 2. Is that what you're asking? Yeah. And same thing with the x's and the y's. But like this 2, because you had 7 2's and you can only make 2 groups of 3, you have this leftover 2 that stays inside of here. Yeah, good question. Any other questions? Okay, cool. If you guys want to open up your homework, I'm going to start on question 6 because this one has a negative number. Okay, so on my question 6, I'm finding the cube root of negative 108 AB to the 7th. So the main thing I want to point out here is what you can do with a negative. Because remember, you can't square root a negative or 4th root or 6th root or basically any even number root a negative, but you can do it for odd number roots. Because if you think about like negative 1 times negative 1 times negative 1, that's negative 1 cubed, but it would equal a negative number. So it's fine to take the cube root of a negative. And that's essentially what we're going to do here, because I'll take my number part and I'll say 108 can be factored into 12 times 9. 12 can be factored into 3 times 4, which can be factored into 2 times 2. 9 can be factored into 3 times 3. So if I wanted to rewrite this, I could rewrite it as the cube root of 2 times 2 times 3 times 3 times 3, because those were all of my prime factors that I broke the number up into. And then for the negative sign, I could just think about it as a single negative 1. But since I'm trying to do a cube root, I could also think about it as negative 1 times negative 1 times negative 1. Because if you do negative 1 times itself 3 times, that will just equal a negative. I'm going to think of my negative as being a -1 times itself 3 times. Everybody good with that? And like if it was a fifth root, it might be more useful to think about as a -1 times itself 5 times. The main thing is just that you make sure that however many -1s you list, that it really does multiply to whatever negative you're looking for. So we say, okay, that's the number part. Then I also have a single A and 7 B's. So that will look like that. Then you just go through and look for triples. So if I take the cube root of -1 cubed, that's going to equal -1. If I do the cube root of these 3 3's, that's going to be a 3. The cube root of these 3 B's will be a B. These 3 B's will be another B. And the stuff that's left over in my cube root are these 2 2's, which will be 4. And then there's an A and a B left over. And so then I could simplify the outside to be -3b squared times the cube root of 4ab. So that's how you would work with a negative. You guys have any questions on that? Yeah. Say that again a little louder. Yeah. The 4 came from the stuff that's still left. So, whoops. Yes. Yeah, because the 2's didn't have enough to get a cube. Same thing with this A and this B. And so you just multiply everything that's left. Yeah, good question. Yeah. Because I'm doing the cube root, so it's the way I'm thinking about the negative sign. Because the negative sign could be thought of as just one -1, but you could also do -1 times -1 times -1, because that equals -1. So yeah, that's one of the nice things about having a 1 is no matter how many times you multiply it, it still equals 1. But you want to make sure you get the right amount of negatives to make it like whatever type of root you're working on. Yes, exactly. All right, so that's question 6. I think there was, this concept is important. I think it's on question 9 and 10. On most of the questions, it will say that the variable, you can assume that the variables are positive, but on some of them, it will say do not assume that the variables are positive numbers, in which case you need to use an absolute value to make your answer positive. So like in this case, if you have the square root of 36y squared, using what we've learned so far, you could say, well, the square root of 36 is 6. The square root of y squared would be y. And you might say, well, that's just the answer. However, if the y happened to be a negative number, because they said we can't assume it's positive, you would get the square root of something positive equals a negative number, which doesn't make any sense because the square root of something should always be a positive number. So if you can't assume that the variables are positive, then you just need to put absolute value signs around your answer to make your answer positive. And that will be applicable on question 10 as well, because on question 10, they're asking you to find the square root of a polynomial. So just like we did with numbers, if you're asked to find the square root of a polynomial, you want to get it into factored form. So you'd say, okay, since this is a trinomial, I can use my trinomial trick and multiply 9 times y squared. What are 2 things that multiply to 9y squared but add to 6y? I think I heard someone say 3y, 3 and 3. That would work, especially if they were both positive, because 3y times 3y would equal 9y squared, and 3y plus 3y would equal 6y. And then you get y squared plus that plus 9, split it into 2 groups. The first group has a y in common, which leaves y plus 3. The second group has a 3 in common, which leaves y plus 3. When you pull out the common y plus 3, you get y plus 3 times y plus 3. So essentially, this is the square root of y plus 3 squared. because when we got the polynomial into factored form, you had y plus 3 times y plus 3, which is y plus 3 squared. But if you square root something that's squared, that's going to equal just the thing that you are squaring. So it's going to equal y plus 3. However, if they said that we can't assume that the variables are positive numbers, your answer to a square root problem has to be positive. And so if our answer is y plus 3, but y was a negative number, our answer might end up being negative. So we're just going to put absolute value signs around our answer to make sure that it's positive. And the absolute value signs are not necessary if the instructions say you can assume the variables are positive. Some of your problems will say that. But if it says that you cannot assume that they're positive, then you need to put absolute value signs around your answer. The other question I wanted to go over is question 17. So on question 17, you're asked to simplify an expression that has a square root in it. So you could just start simplifying this because 3/12 can reduce to 1/4, but it would probably be easiest if we first simplified the square root part. So to simplify the square root of 48, we need to factor 48. So it can be 4 times 12, 4 can factor into 2 times 2, 12 can factor into 3 times 4, 4 can factor into 2 times 2. So the square root of 48 is the square root of 2 times 2 times 2 times 2 times 3, because those are all of these prime factors here. And since I'm square rooting it, I'm going to look for squares or pairs of the same factor. So the square root of 2 squared is going to equal 2. The square root of another 2 squared is going to equal another 2. And times by the square root of 3, it looks like this is going to equal 3 times 2 times 2 times the square root of 3. So this 3 right here came from this 3. So I'm doing 3 times the square root of 48. So the 3 stayed there, but the square root of 48 became 2 times 2 times the square root of 3. And you could multiply all of those together. So if you do 3 times 2 times 2, that equals 12. Sorry, I forgot to write the bottom of my fraction, but 3 times 2 times 2 would equal 12. So you'd get 12 times the square root of 3 over 12. And because everything in that fraction is being multiplied or divided, you could cancel out the 12s and your fully simplified answer would just be the square root of 3. Now on question 18, this one's kind of similar, but a little bit different, because in the top of the fraction, you don't have things that are multiplied, you have things that are subtracted. So in this case, you need to get it into factored form before you can cancel anything out. But first of all, let's go ahead and simplify the square root. So the square root of 45 can be split up into 9 times 5. 9 can be split up into 3 times 3. So the square root of 45 can be 3 times 3 times 5. I'm looking for the square root of things. So I want to look for factors that are squared. So the square root of 3 squared is just going to be 3. The square root of 5 can't be simplified any further. So this is the simplified version of the square root of 45. So I can rewrite that and I'll have 12 minus 3 square root of 5 all over 9. Now it's possible I might be able to reduce this fraction if they have a factor in common. But you have to have the top in factored form before you can cancel out any common factors. Because what we have right now is 2 terms, and those 2 terms are being subtracted. So we want to look at those 2 terms and say, well, what do they have in common? Yep, they both have a 3 in common. So I can write this as 3 times 4 minus the square root of 5. Is everybody good with how I did that? Pulled out the common 3 from both of them. And now this is in factored form because I have 2 things that are multiplied on the top of my fraction and it's divided by the 9. So since it's in factored form and everything's being multiplied or divided, I can say, well, 3 over 9 will reduce to 1/3 because 3/9 equals 1/3. And so my fully simplified expression for this would be 4 minus the square root of 5 all over 3. And that would be my final answer. Any questions on that? Goodness. Okay, that was the last example I wanted to go over. If you guys have any questions as you work through your homework, let me know. Oh, there was actually one question that a lot of people asked questions about last class. I think it was question 13. So on question 13, it gives you this formula and then it gives you some numbers and things that you can plug in. And on this one, they don't necessarily want you to simplify, they want you to calculate out the decimal, because one way that you can simplify roots as well is to approximate them as a decimal by just typing it into your calculator. So if it says round to at least 1 decimal place, you don't have to worry about doing all of this stuff where we broke it up into factors and things, because they just want you to type it into your calculator and say approximately what is the square root of 45. But the thing on question 13 is that you're going to be taking a depending on what your number is. So in this case, my t was 6. So I would be taking the 6th root of whatever my a was, which I think is 7,000 over my p, which would be 35,000, then minus 1. So ultimately what I want to do is I want to figure out what that is, calculated in my calculator. But your calculator probably doesn't have a 6th root button. So the way that you would type this into your calculator is you would do 7,000 or whatever your number is divided by 35,000. And then you would raise this to an exponent of 1/6. Because remember, a fractional exponent is the same thing as a root. And that's the way that you type it into your calculator. And then you would subtract 1 from that. That should give you a decimal, and they asked you to give the answer as a percent. So you would then change the decimal into a percent from there. So the main thing I just wanted to mention here is when you're calculating out a 6th root or whatever type of root you're looking at, you just raise it to a fractional exponent. So I'll let you guys work on your homework, and if you have any questions, let me know.